Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, maximum difference. So what the problem is saying is we'll be given an array of integers. The task is to find the maximum absolute difference between the nearest left smaller element and the nearest right smaller element of every element in array R. If for any component of the R, the nearest smaller element doesn't exist, then consider it as zero. Okay. So let's see what the problem is trying to say. Okay, so we'll be given an array. Okay, and for each element, we want to find the nearest smaller element, left smaller element and right smaller element. Okay, and for every element, we want to go through the every element and we want to find the maximum absolute difference between these smaller elements. So let's see what we can do. For example, right? Let's have two arrays, ls and rs. Okay, so for this the first element, right, 2, right? So what will be the nearest left smaller element? So this is the this array will hold the all the left smaller elements, okay, of every element, and this array will hold all the right smaller elements of every element. Okay, so for this 2, right, what will be the nearest left smaller element? Definitely it is going to be 0 because this is the first element. There is no element before this element. Okay, for 4 it is going to be 2. For 8, it is going to be 4. Okay. For 7, it is going to be 4. Right? For 7, again, it is going to be the same. It is going to be 4. For 9, it is going to be 7. For 3, it is going to be all the way to 2. Right? Okay. Okay. For RS, let's see what will be the, so we'll, for RS, right? We'll start from the last element. Okay. So what for 3, which is the nearest right smaller element, definitely it is going to be 0 because it's the last element. For 9, it is going to be what? It is going to be 3. For 7, it is going to be 3 again. For this 7, it is going to be 3 again, right? For 8, it is going to be 7, right? Nearest right smaller element. For 4, it is going to be 3. And for 2, it is going to be 0 because there's no other element on the right side which is smaller than 2. Okay. So yes, so we have the left and right smaller elements. Now what we want to do is we'll go through each uh, we'll go through the elements, okay, of both ls and rs at the same position, and we'll check the maximum absolute difference. So here it is what? 0. Here it is absolute difference. For 2 and 3 it is 1, right? For 7 and 4 it is going to be 3. For 4 and 3 it is going to be 1, right? For 4 and 3 again it is going to be 1. For 7 and 3, right, it is going to be what? 4. Maximum absolute difference. For 2 and 0 it is going to be 2. Okay, so out of these elements, right, out of these differences, the maximum difference is 4. So we are going to return the same. If you see here, it is 4, right? Yeah. So this is what the ask is. Okay. Now how can we solve the problem? So now let's first see the brute force approach. So what we can do is we can iterate through the array. Okay, for okay, all the elements to the array. What we'll do for 2, right? We will iterate through the remaining elements, right? And whichever smaller element we find, okay, for each element we are going to compare, we are going to run a for loop the for the for the remaining elements. Okay, for the remaining elements, okay, to find the smaller element. So in this case the time complexity rate is going to be O of n square. Okay, so this is a brute force. So we need to see whether there is an optimized approach, or there is an optimized approach to solve this problem. Okay, so definitely there is an optimized approach. Okay, so what we can do basically is we can have a stack. Okay, we'll have a stack basically. Okay, so let's start. Okay, so here let's have a stack and we'll have these two arrays. Okay, we'll have these two arrays. Now so what we're going to do, so first let's calculate the left smaller elements. Okay, so definitely for the first element 2, it is going to be 0, definitely, because there's no element on the left side of 2, right? And what we are going to do for the first element, we are going to insert 2 in the stack. Okay, 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 now let's move to the next element 4, right? So we are going to check, we are going to compare this 4 with this 2, with the top element, or with the peak element of the stack. Okay, now since this peak element is smaller, right, than this 4, so we are going to add the peak element. Okay, add the peak element on this in the left smaller array. Okay, and what we're going to do, we are also going to insert 4 here. Okay, now we'll come across 8. We'll check. Now yes, we'll compare 8 with the top element of stack. Okay, which is 4 is smaller, so we'll add 4 here. We'll add 4 here and we'll add 8 over here. Okay, Then we'll move to the next element. We'll compare with the top element. No, it is than 7. Then we are going to pop 8 out. Okay, and we'll now check with the next top element of the stack. Definitely 4 is smaller. Then we are going to add 4 here. Okay, and what we'll do, once we add 4 here, we are going to add the same 7 in the stack. Okay, now again we'll come here, we'll check, we'll compare with the top of the stack. Okay, now this is equal, right? So we will pop this out. This is not lesser. Okay, now again for 7 we'll compare with the top element. It is 4. So 4 is lesser. So we'll keep 4 here. We'll add 4 here. And also we'll add 7 here. This particular 7 we'll add in the stack. Now we'll come here 9, right? So 9 again, we are going to compare with the top element. This is smaller. The top element is smaller. Then we are going to add, for 9, we are going to add 7 here. Okay, and also in the process, we are going to add 9 in the stack. Okay, now we'll come across 3 here. So 3, so the top element is greater than 3. So we are going to pop this out. We'll compare with the 7. Again, it is greater. We'll pop this out. Compare with 4. This is greater. We'll pop this out. With 2, this. Okay, so now we found smaller. So we are going to add 2 over here. Okay, we are going to add 2 over here. So we have found the left smaller elements. Okay, now we'll do the same process for right smaller elements. Okay, okay. So let's take another stack here. Okay, let's take the stack. Okay, so it is going to be the same stack. We'll just clear this out. Okay, we'll just clear this out. So here will be for the right smaller elements, right? We're going to start with the last element. So definitely, what we're going to do for this smaller for this, right? For this element, the right smaller element, it is going to be 0. It is going to be 0 because there are no other elements on the right side. Okay, and also in the process, we are going to add 3 here in the stack. Okay, now we'll move to the previous element, which is 9. We'll compare with the top of the stack, right? It is smaller. Then we are going to add in this RS array, and also in the process we are going to add 9 on in the stack. Then we come here to 7. We're going to compare this 7 with the top of the stack. Okay, now this 9 is greater, so we are going to pop this out. 9, we are going to pop out 9. We're going to pop out 9. Okay, now we'll compare 7 with 3, the top of the stack, it is smaller. The top of the stack is smaller. We're going to add 3 here. Okay, now, and also we'll add 7 here. Okay, again, we come to 7. We'll compare with the top of the stack. Okay, it is equal. It is not lesser. So we are going to pop this out, pop 7 out from the stack. Okay, now we'll compare with 3. 3 is smaller. So we are going to add 3. And also in the process, we're going to add 7. Okay, now we come here, 8. Again, 8, we compare with the top of the stack, 7. 7 is smaller, so we're going to add 7, and we'll also add 8 into the stack. Okay, now we compare 4 with the top of the stack. Now, 8 is greater, we will pop out from the stack. Okay, again, 7 is, we'll compare with 7. 7 is also greater, we'll pop out from the stack. Now we'll compare with 3. 3 is smaller, so we're going to add 3 here, right? We'll add 3 here. Okay, and also we'll add 4 in the stack. Now we'll compare 2 with the top of the stack. 4 is greater, will pop 4 out. 3 is greater, will pop 3 out. So we are not left with any element. So we don't have smaller element than 2 on the right side. So we are going to add 0. So this is approach. This is intuition behind solving the problem. If you see, it is solving in O of n. Okay, O of n with the cost of extra auxiliary space. So we need to take extra auxiliary space of O of n. Then we are able to optimize this approach. Okay. Now simply we have this LS and RS, and I have already explained this. We'll compare right the elements at the same position, and we'll take the maximum absolute difference. Okay, so this is the intuition behind solving the problem. Okay, let's go to the code now. Before going to the code, I'll request you to subscribe to my channel, like the video. If you subscribe to my channel, it will really be helpful to me. Okay, so let's quickly code the Java code first, followed by C++. Okay, so as I said, we'll take a stack, integer st equal to new stack, right? So we have a stack here. Then what are we going to do? We're going to take 2 arrays, ls. Let's first take the ls array, int. Also take the n, arr.length, right? Arr.length. We have n here. Okay. So what are we going to do? So first of all, we are going to, the ls of 0, it is going to be 0 only. Okay, because definitely there's no small element, or there are no elements before the first element, right? So also we are going to add st.add the first element of the array. Okay, now what we're going to do? we will start with the second element. Okay. And we will compare this element. For example, what we're going to write, st first of all is empty. If it is not empty, then only you can compare, right? And we'll compare air of I. If it is, or let's take vice versa, st dot peak, if it is greater than equal to air of I, right? Air of I. So in that case, what we need to do, we want to pop the element out, because the element at the top of the stack, it is greater or equal to than the array element. We don't want that. We want smaller element, right? So we're going to pop that out. Okay. And then what we're going to do, ls of I. Okay. We're going to check if st is empty. If we didn't find any smaller element, right, on the left side, then what we're going to do, we'll assign 0 to that particular position. Okay. Else, we are going to, what we are going to do, st dot peak. We are going to assign the top of the stack. Okay. And also, once done, we are going to also push the current element of the array. Okay. So in this way, we are building the left, smaller element array. Now we are going to clear this stack out, and we'll repeat the same process for um, right rs. So let's maybe, if we can use, let's use this. So we'll have rs, right? And what are we going to do? The last element we are going to assign 0, okay, of rs, right? Because there are no elements after the last element of the array, right? And what are we going to do in the, sorry, my bad. It should be push and not add. Push, right? Here also it should be push. So what are we going to add? We are going to add the last element. I've already explained this last element, right? And what are we going to do? We are going to start this and from the second last element, and it is going to be 0, greater than 0, and minus minus. So what we are going to do, we are going to follow the same process here. We are going to compare the top of the stack with the array, right? If it is greater than equal to, if it is greater than the current element in the array, then we are going to pop the elements out. Okay. So here again, if it is, right, if the stack is empty, we'll assign 0. Otherwise, we'll assign the top of the stack. Okay. Whatever is top of the stack. And also we are, will push that particular element. Okay, so we have the left and right smaller arrays. Now simply what we're going to do, we are going to have a difference, right? We're going to check the difference. Int I equal to 0, I less than n plus plus I. So what we're going to do here, so diff equal to math dot max, right? Diff comma math dot absolute. We are going to take absolute of ls of I minus rs of I. Okay, so whichever is greater, so it will be assigned to diff, and simply will return diff at the end. Okay, so this is the code. I hope you have got the code. Please, if you've got the solution, please subscribe to my channel, like the video. It will really be helpful to me. Okay, let's submit it. Yes, the test cases are passed. Let's quickly see the C++ code. Please subscribe to my channel. Okay, so here is a C++ code. We are taking the size of the n, right? N in the size of the array. Okay, we are taking stack. We are taking two arrays, LSRS. What we are doing here, we are assigning the first left smaller element as 0, right? And then we are pushing the first element in the into the stack. Okay, and then what we are doing, here we are checking, right? Here we are checking if the top of the stack, if it is greater than the current element, greater than equal to current element, then keep on popping until the stack is not empty. If the stack is empty, assign 0, else assign the top of the stack. Okay, and finally also push the current element on the stack. Here what we are doing, if it is not clear, if it is not empty, clear it out, because we want to do the same operation for the right smaller elements, right? So here what we are doing, we are assigning the last element of rs, that is a right smaller array, as 0, right? And then we are pushing the last element in the stack. Here we are starting with the second last element. We are comparing again the top of the stack with the current element, right, of the array. If it is, we'll keep on popping until the stack is empty. Here we are doing the same operation. Rs, if If there's some element in the top in the stack, then we are going to assign the top to the rs of I, right? And finally we'll push in the element into the stack. And here what we're doing is we are calculating the maximum difference, right? The maximum absolute difference. Okay. So yes, so this is a code. I hope you have got the solution. Please subscribe to my channel, like the video, have a happy, healthy, and a great day. Thank you so much.